Tell us your name and tell us about your project.
Oh, well, my name actually is Clinton Izoba, and you see, I'm actually a scientist from Nigeria, and in my project, which I worked on with Sir Arthur Eddington and other astronomers who were his doctoral students, astronomers in Africa, astronomers over in Brazil. We had two teams actually. With these astronomers, we actually just had our project published this year actually, and in this project that we did in this experiment, you see, we tried calculating the relative position of the stars relative to the sun, of course, during a solar eclipse and before a solar eclipse. We took different pictures of the same patch of the sky with an eclipse and before an eclipse. And so using those two pictures, like I said earlier, we were able to compare the relative position of the stars to the sun and see what change there was and calculate that change.
What were you guys trying to do or find?
Well, you see, we were actually trying to find proof. We were trying to prove Einstein's theory of general relativity, which is a mind-boggling concept that actually predicts that the gravity of a massive object, as massive as a sun, as massive as a sun, can actually curve space-time around it. It can create curvature. It can bend space-time, the fabric of space-time around it. And what that would do to light, actually starlight, is that it would bend it. Because space-time around the sun is curved by its gravity, light, which normally travels in a straight line, would actually be curved. And you see what that curving of the light would do. It would create to us an illusion of seeing the star where it is, where it's not. Uh, what would happen from that light being bent is that we would see the star where it's not. We would see where it's not as opposed to where it actually is before an eclipse. And you see, that's actually what Einstein's theory of general relativity predicts. And that's actually what we saw. We were able, using the pictures from before and after the solar eclipse, we were able to calculate the relative position of the stars, and we were able to see that 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 the sun actually bends the light of stars. And this had to be done in an eclipse because the sun is so bright that an eclipse is the only thing in nature that can actually turn off, really, that can actually switch off the sun for 8 minutes. So that's why the eclipse was important. That's why we had the experiment, and that's what we were able to see. We calculated the deflection of the star from its actual position, and the value we got for that deflection was 1.74 arc seconds, which is the value predicted by Einstein's theory of general relativity. And that's what we saw. Newton was wrong. Newton thought that it would be around half that value, but Einstein's theory of relativity showed that it would actually the light would actually be bent by a great deal, by a great amount of deflection, and that's what we discovered. That's what we did. We proved his relativity theory, and so that was the goal of our project, which we achieved.
Where did the project or experiments occur?
Well, the project actually happened in the island of Principe. It's a small island off the coast of West Africa. It's actually where I go for vacation during the dry season, or rainy season too sometimes, really. Uh, yeah, our project, we did it there, and our project actually was actually also located in Brazil. Really, this was an experiment that took place in two different places. The first place was Sir Arthur Eddington, in the island of Principe, and the second place was in Sobral, which is in northern Brazil. There, Sir Arthur Eddington sent another team of astronomers to take pictures of the same eclipse during its 8 minutes showtime. So yeah, so that's where the project was located. It was located in Principe, the island where I go for vacation, and and it was conducted in Principe, and it was conducted in Brazil.
Okay. What other significant events were happening at that moment in time?
World War One. That was actually a horrible time, really. I mean, it actually almost ended. It was a threat really to our experimentation, to our experiment, because Britain, at the time was at war with with France and Germany, and so what that meant for us scientists actually was that we would be conscripted. That means that uh, that we as citizens of Britain would become soldiers to fight. But luckily, I was able to escape conscription, and so was Sir Arthur Eddington, and so we were able to conduct our experiment and not have it be ruined by, I guess, having to serve in the military. So that was the awful event. But luckily, we had our project done in time. This was the world event that was the context of our experiments of World War One and its ending.
Who else was involved in the project?
Well, actually, like I mentioned earlier, it was Sir Arthur Eddington was involved. His doctoral students were involved. They were the astronomers who worked with us, and you see other his other astronomers. There was also another team of astronomers in northern Brazil, in Sobral, Brazil, that were taking pictures of the same eclipse. That were taking pictures of the same eclipse that we were looking at. They were there. They were helpful. Their own pictures just enabled us to give even more accurate uh, measurement of the deflection of starlight.
What was your role in the project?
Well, my role in the project was taking pictures along with the other astronomers. We needed as many as possible, really, because that's what we do in science. We repeat our calculations. We repeat our experiments. It's about repetition to get more accurate results. So I did that. I took pictures of the sun during the solar eclipse, but I also took pictures of the sun before the solar eclipse, because again we're comparing these pictures of the eclipse to the patch of the sky when there's no eclipse, so we can get an accurate calculation of the deflection of starlight. So I took the pictures 2 months prior to the eclipse because I was already there in Principe, where I go for vacation, like I said, and I also made sure that our equipments were well maintained, because these are very sensitive instruments that we use in calculating uh, the deflection of starlight. And of course, I also made sure we all had a residence to stay, because we actually stayed in my vacation residence, my summer residence, if you can call it that, in Principe. So of course, when Arthur Eddington came in to Africa, of course I received him, and he stayed at my house with his doctoral students, with the other assistants.
What impact did you have on the physics community?
The physics community, really, that such a narrow question. What impact did it have on the entire world? We proved Einstein's theory of general relativity, and in doing so, we revolutionized our understanding of space and time. Really, space and time are seen as relative now, not absolute. So really, this kind of mind-boggling concept is dumbfounding to both the physicists and the non-physicists alike. Really, so that was the big impact I had on the world, on the physics community in particular, and in the world, just a revolution of how we normally understand space and time.
How did you meet Eddington?
How I met Eddington. Well, you see, I was actually the adopted son of Sir Frederick Lugard, who was back then the colonial administrator of Nigeria, and he saw my passion for science, for astronomy, and so he sponsored my scientific education. Even though I wasn't English, I'm not a European, clearly. But despite that, thanks to his help, I was able to get my degree in the University of Cambridge, and that's where I met Sir Arthur Eddington, and we also worked together. We also worked together in the Department of Astronomy in the University of Manchester. And so when he needed someone to help him with his experiment, when he needed a good residence to stay in Principe, uh, he asked me, and of course I helped him, and I helped in conducting this experiment, which has really changed our views of space and time, and I'm happy I was a part of that. It really was. So thank you for asking.